Hey, good morning, everybody. I hope you're doing fantastic. We are doing basically the first week of November. This is our last new material before the test next week. Next week, we will have a test on Monday, pre-test Monday, sorry, and the test on Wednesday. I won't be around for the test on Wednesday. I'm leaving Tuesday. So make sure that if you have any questions, you ask them by Monday night. Um, we'll do a pre-testing class on Monday, so that would also be a very good time to ask me any questions that you might have. Now, this week we will review the homework from lesson 16. We'll do that in just a moment. We will do the rest of lesson 17, and then we'll do lesson 18. And finally, we will finish up with a quiz on Wednesday. So that's the work for this week. Next week is an all test week. When we get back from that, we've got about 2 weeks worth of new material to do. And then we've got a week of a pre-test and a test. And then it's final exam review after that. So we are definitely turning the corner, but there are a lot of grades that are going to be handed out between now and the end of the semester. So you really gotta, you've been given, for the most part, most students have been giving a very strong effort. You just gotta really make sure you sharpen your focus and that you get everything that you can possibly do down pat over the next couple of weeks so that you set yourself up to maximize your grade. Okay, here's the lesson 16 homework answers. Again, you can do stop and start. So I'm just going to pause for like 3 or 4 seconds, and then I'll go to the next one and the next one and so on. Okay, so as we continue to go through here, you know that because you're watching a video, there can be no interchanges between us about what you may have done wrong. So you can always send me an email, reach out during office hours, or talk to somebody in the class. All right, so those are our homework answers. Now, let's get into the pregame stretch, which is right here. And you can either download this from Moodle and do them, or you can get started on them. Now, I'm going to do the same thing with stop and start. So if you're taking it from the recording here, just stop your video, answer the questions, and then continue it, start it up again afterwards. And I'll pause for just a few seconds. When you see such a concentration of questions, you can assume that on our next exam, you're going to see questions like this. That's a pretty safe assumption. Okay. And as far as your answers to the pregame stretch go, here they are. Just get this out of the way. There you go. So you can see it fully. Okay, so there were the answers. Again, any questions, reach out and we will take care of them. Okay, next up is our slideshow. And I hope that you get to see the full page. I don't know if I need to swap displays or not. Let's see what happens. Okay, so I think that you're seeing just a single slide right here and that you're not seeing the presenter view notes. I cannot be 100% sure of that, but I think that's where we're at. Okay, so today is going to be the third and final day of function-focused lessons. So let's go on and see our agenda. We have already taken care of the homework review, the pregame stretch, and the pregame stretch review. So we're completely done with 1 and 2. Let's do a little bit of recent work recap. Go ahead, factor. using AM or the graphing calculator. Throughout these slides, you're supposed to do stop and start, and I will then just pause for like 5 seconds on my end and then show you the answers. Okay, so I have to multiply out to equal 24 on the first one, add up to negative 11. The two numbers that do that are negative 3 and negative 8. So the factors are x minus 3 and x minus 8. If you use the calculator, you would take the last number divided by x, which would be 24 divided by x, and then for y2, you do the same exact thing plus x, and then in that third column, when you go to table, you look for a negative 11. You look for what they're going to add up to, and then you look at the two previous columns, and you'll see negative 3 and negative 8. Okay, for number 9, you have to multiply out to negative 72, add up to 1. That's positive 9 and negative 8. So the factors are x plus 9 and x minus 8. If you chose to do it on the calculator for y1, you'd want to put negative 72 divided by x. Always a good habit to put negatives in parentheses. And then calculator for y2 would be the same exact thing in y1 plus x. That's always the case with y2. Same exact thing as y1 plus x. And then you're going to look for a positive 1 in the third column and look at the two previous columns. In either order, it will tell you 9 and negative 8. Okay, factoring trinomials with a lead coefficient other than 1. This is a little bit more challenging. Now, I should tell you that I have the hardest time saving these PowerPoint files. That's why sometimes there are mistakes on them. I correct them. I run through, I look at it, I see if it's correct, I try to save it, and it keeps giving me this message that says another user has access to or is using this file right now, so it won't allow me to save them. So the only thing I can possibly do is highlight all of the slides and create a brand new slideshow and put it in there. And sometimes when that happens, things are not quite as perfectly aligned as they're supposed to be, like this one. This should be a little bit more aligned, but it is what it is. And then if I try to save this one, it would give me a hassle in trying to save this one. So it is what it is. It's a little bit sloppy looking, but that is why. Okay, let's have you try the first one and the second one here, numbers 8 and 10. Factoring trinomials with a lead coefficient other than 1. Remember, there's a plan A and a plan B. Begin. Okay, so I assume you have done stop and start. In the first case, I look for a common factor of 2. It's not there. So I multiply the last number by the leading coefficient. That means I multiply it all by 2, and I come up with x squared minus 11x plus 24. And Lord knows we just factored that a few minutes ago. So I get x minus 3 times x minus 8. But remember, I have to balance that out because I changed the question when I multiplied the last term by 2. So I'm going to balance it out by dividing back by 2. And that makes the one on the right simplify to x minus 4, right? Because 8 over 2 is 4. And on the left-hand side, I have to use the elementary school trick like you're converting mixed numbers and improper fractions. Multiply by 2, and I get 2x minus 3 times x minus 4. If you check, 2x times x is 2x squared. 2x times negative 4 is negative 8x. Negative 3 times x is negative 3x. Negative 8x and negative 3x do indeed add up to negative 11x. And negative 3 times negative 4 is 12. So we know that that works. For number 10, I look for the lead coefficient, or I look for a common factor, and I see, yes, I do, it's 5. So that leaves me with n squared minus 2n minus 3. I factor that using either AM or the calculator, and I get 5 times n minus 3 times n plus 1. Okay, a little bit of difference of two perfect squares work. Okay, so for the first one, remember, with the difference, of two perfect squares, basically what you realize is that there's really a plus 0x in the middle of all of these. And because of that, you need like plus and minus to be the same number so that you add up to 0. And that means I'm going to end up square rooting both of them. So I get x plus 11, x minus 11, x plus 7, x minus 7. This one's a little interesting. There's a lead coefficient of 9. But that's square rootable, so that's 3x plus 10, 3x minus 10. And for the last one, 2x plus 9, 2x minus 9. All right, let's take a look here. Factor completely. That completely is code for there should be at least 2 steps involved. Go ahead, factor all of those completely. Okay, so factoring completely, the first one, they share a 3 in common. That gives me x squared plus 3x minus 10, which breaks down to x plus 5x minus 2. The next one, they share an x in common, which gives me x squared minus 25 when I factor that out, which gives me x times x minus 5 times x plus 5. And it's at this point that I really want to pause and focus on something and emphasize. It's very important that you put down the 3, the x plus 5 and the x minus 2 in the first one, all 3 parts. In the second one, the x minus 5, and the x plus 5, all 3 parts. Here we have, again, a difference of 2 perfect squares, but the square root of x to the 4th is x squared. So I get x squared plus 25, x squared minus 25. Now the x squared plus 25 can't be factored any further, but x squared minus 25 can. It's x plus 5, x minus 5. It is another example of the difference of 2 perfect squares. Okay, and the last one would be 9x plus 4, 9x squared, sorry, plus 4, and 9x squared minus 4. And that 9x squared minus 4 is also factorable. Again, it's a second difference of 2 perfect squares. That gives me, I wrote the wrong answer down. That should be 3x plus 2, 3x minus 2. So I just typed out the wrong answer. I apologize. Here's my ding, 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 daily dumb mistake. 9x squared plus 4, and then 3x plus 2, 3x minus 2. So one more time. 9x squared plus 4, as it says above, and then 3x plus 2, 3x minus 2. Okay, so quadratic formula question. There's the quadratic formula for you as a reminder. And there's the question we need to see you do. Go ahead. Okay, so it's telling you to use the quadratic formula, so you know right away to go with a is 1, b is 2, c is negative 19. And here's the formula. So the negative of b is negative 2 plus or minus the square root of b squared, which is 2 squared, minus 4 times a is 1, and c is negative 19 over 2 times 1. So x is negative 2 plus or minus the square root of 4 plus 76 over 2. 4 and 76 make 80. Negative 2 plus or minus the square root of 80 over 2. Negative 2, and the square root of 80 is about 8.94. So negative 2 plus 8.94, negative 2 minus 8.94, each of them over 2. That gives me 6.9 over 2 and negative 10.9 over 2, which break down to 3.45 and 5.45. If it had asked for radical form, and we're not really going to do simplest radical form in here, we talked about that before. There's the radical. Okay, solve for all values of x. Now, we haven't done one like this, but all you need to do is put the x over 1 and cross multiply. Go ahead. Okay, so when I cross multiply, I get x times x plus 1 equals 2. Distributing the x, I get x squared plus x equals 2. Subtracting 2 from both sides, x squared plus x minus 2 equals 0. Factoring, x plus 2 times x minus 1 is 0. Maybe it's the guy on the left, maybe it's the guy on the right. Subtracting 2, adding 1. Bottom line is, I get x equals negative 2, and x is equal to 1. Okay, next up, here we go. What type of function could be used to model the data shown in the accompanying graph? And then there are 4 choices. Go ahead. Okay, so when we investigate this one, the first thing I want to do is mention that we have not discussed a trigonometric function at all, let alone trigonometric graphs. You may remember them from when you were in school. Basically, there are these curves that look like the curve I just put up there, and this curve in the picture doesn't look anything like that. So it's definitely not trigonometric. One of the reasons I wanted to put this question up there is to try to increase your test savvy. If you ever have a multiple choice question and you see a choice that you cannot remember ever seeing within a course, it's probably what you call a distractor. And if you go for it, it's very dangerous because it's highly unlikely it's the answer unless you can 100% eliminate all the other choices. And in this particular case, one of the other choices is the correct answer. So it's not trigonometric. The correct answer is exponential. It's not quadratic because it doesn't form a gentle U like a parabola, and it's not linear because it's not a straight line. So it is exponential, okay? Usually the exponential gets bigger and bigger and bigger, like my cursor that I just moved. But that's when the exponent is a positive number. When the exponent's a negative number, it just gets smaller and smaller. Okay, next up, we have a laundry owner's estimate of her weekly profits in dollars is given by this equation, where W represents the number of workers she hires. So again, I'm not really expecting you to necessarily get this question right. What I do want to do is show you one of the powerful things about the graphing calculator and how that could be used. Now, you will not be tested on anything like this, but power of a graphing calculator. Under y equals, enter negative 4x squared plus 160x. Now you might be saying, well, what are you doing? The problem says w. On a graphing calculator, the variable is xt theta n. It's just whatever the variable is. It doesn't matter what you call it. And then next you go to graph. And when you graph it, you'll see a graph that looks like this. I'm cutting off the bottom of the graph because the graph gets really tall. If you don't see the graph in your graphing calculator, just go to Window and do Y maximum and do Y maximum of 1620, and you'll get the top piece of the graph like this. Your graph will look slightly different, but similar nonetheless. And you can see clearly there's a maximum here. There's your point right there. And it works out that that is 20 units to the right. Each one of these little grids here is equal to 5. So it's 5, 10, 15, 20. There's your maximum right there. It's at 20, 1600. So the number of workers that she should hire to earn this profit is 20, and the profit she'll earn is $1,600. Okay. All right. Last question for this. Nope, I'm sorry. We got one after this. Second to last question for this recent work recap. And again, this is a little bit different than we're used to, but I think we can work our way through. And, you know, of course, we'll do it again on Wednesday's lesson. We'll just change the numbers a little bit. A rectangular patio measuring 6 meters by 8 meters is increased in size to an area measuring 150 square meters. If both the width and the length are to be increased by the same amount, call it x, what is the number of meters to the nearest tenth that the dimensions will be increased? Okay, give it a shot, and then I'll take you through it. So there's the rectangle that we start with. The sides are 6 and 8. Now I'm going to increase each of those, the length and the width, by a factor of x. So it's not even a factor of x, I'm sorry, by a distance of x. So each of those goes up by x. So now, what are the new length and width of the rectangle? Because remember, area is length times width, so I have to know what the length and the width are. And the new width is x plus 6, because from here to here is 6, and from there to there is x. So altogether, you're adding them, it's x plus 6. Likewise, from here to here is 8, and this is x, so add them up, and you get x plus 8. Okay, so how do you solve it now? Well, length times width is area. So if I do x plus 8 times x plus 6, I'm going to get 150. So double distribute, that's x squared plus 14x plus 48 is 150. It's a quadratic equation, so get it all on one side. Subtracting the 150, and I get x squared plus 14x minus 102 is 0. A is 1, B is 14, C is negative 102. How did I know to go directly to the quadratic formula? here's the phrase, to the nearest tenth. That is a hint, strong suggestion, command, however you want to look at it, from the person making the question that you use the quadratic formula, because when we factor, we don't get tenths. Only with the quadratic formula do we get tenths. So, again, A is 1, B is 14, C is negative 102, and there's the formula to put them in. All right, first thing I do is just substitute all the values. Now I start doing some calculations, right? Because 14 squared is 196, and negative 4 times 1 times negative 102 is positive 408, and then 2 times 1 is 2. Now, 196 plus 408 works out to be, I believe, 604. And then if I square root that, I get 24.6. So one answer is negative 14 plus 24.6 divided by 2. The other answer would be negative 14 divided by minus 24.6 divided by 2. The problem with that answer is then x would be negative, and it doesn't fit the context of the problem. So adding them up, negative 14 plus 24.6 is 10.6, divided by 2 is 5.3. And then that's how much you need to increase it by. And I did check it. I've substituted the 5.3 in there, and it did check. Okay, let's see if you remember how to write inverse functions. Try both of them. Go ahead. Okay, so remember, you switch the x and y, solve for y. Looking at the first question, I switch the x and y. Now I solve for y. Minus the 35, dividing by 5, and I get y equals x over 5 minus 7. So that's the process, always the same. Switch the x and y, solve for y. What's the inverse function here? Switch the x and y, solve for y. Add 7, divide by 2. Now you got to square root it, because we got to square root y squared to get just y. So the square root of x plus 7 over 2 is equal to the square root of y squared, which is the square root of x plus 7 over 2 is y. And those, folks, are real strong recap of everything we've been doing. The next video